Right. Good evening, everybody. In the last class, I have ended the thermal power plants in detail. We have covered all the parts of thermal power plants, each and every component, advantages, disadvantages. Okay, starting from installation of thermal power plant to parts, components of thermal power plant, advantages, uses of thermal power station. Okay, I mean the various methods. What is its efficiency? How it can be improved? What are the various types of components which are available, what all techniques are available in thermal power plants. Okay, we have completed with every part of power systems, right? With every part of thermal power plant, right? In the last class, I have given the introduction to hydroelectric power station. Also, I have told that I have told some basic definitions regarding hydroelectric power station. Hydroelectric means we are trying to generate electricity by using water. Okay, directly we are not getting electricity from water. Okay, what we are doing is we are storing the water at a particular height, means your water is gaining potential energy because of that height. Okay, as your water is having potential energy, that is getting converted into kinetic energy. I mean, you are trying to trying to flow that water which is at a very heighted place, and that water will flow, and that kinetic energy of water will cause the rotation of the turbines, and the turbines rotate, and the output of the turbine will be given to alternator, whereas your alternator converts mechanical energy to electrical energy. This is happening in a hydroelectric power station. Right. In the next slides, I will discuss in detail what all the components are there in hydroelectric power station, what are its main components, what all you require. Okay, everything what we need to deal, what we learn in hydroelectric power stations, we will let us see in the next slides. Right, coming to the next slide. Right, it utilizes the potential energy of water at high level for generation of electrical power. Right, this is the block diagram. I mean, it is describing how the energy is transforming from one form to another form. We are not directly taking water, or we are not doing something for water, so that, I mean, we can generate electricity. We are only converting one form of energy to another form of energy. Right, let us see what energies are getting converted in between, and what is the input energy and what is the output energy. Let us study. Okay, right. Input energy is potential energy. Water is stored at a height. Okay, output is electrical energy. I mean, for every whatever may be the power plant, I mean, your output is electrical energy. Either it may be renewable power plants, or it may be non-renewable power plants. Definitely, your output is electrical energy. Your input will depend on the type of plant, or the name of the power plant decides what input you are giving. Right. Coming to the input here, in input is potential energy. What it means, water is stored at a height which is known as potential energy. Potential energy is getting converted into kinetic energy. Kinetic energy is given to the turbine, where it is converting the kinetic energy of the water is getting converted into mechanical energy from with the help of turbine. And your electrical energy, whatever the alternator which you are using, or, I mean, your turbine's output is given to alternator. Your alternator converts mechanical energy to electrical energy. This is the block diagram which shows the conversion of one energy to another form of energy. Right. Next is working of a hydroelectric power station. Let us study. Okay, water used is available at high altitudes, like, okay, whatever the water which we are using, it is available at a heighted place. I mean, the water should be available at a heighted place. Then only you can generate electricity. Okay, I mean, where water will be available at a heighted place is naturally where the water will be available at a heighted place means usually you have natural waterfalls or artificial storage reservoir. Like, I will give an example. I mean, what means, right, in rocky areas or in mountains, if you whenever you go for some tourist places, or in movies, or not, or normally when you look I mean, when you watch television, okay, or when tourist places also you can observe in hills or in hilly areas or in rocky places, or I mean above the mountains, what happens is there will be, I mean, there will be huge stones, right? In between two or three stones, or there will be some down area, or there will be some pot like place where the water after rainfall, after huge rainfall, or after any after the rain comes and goes away, after rainfall occurs, you will find water stored in that place. Okay, like I mean, usually there are some natural reservoirs which are available in our country, and not only in our country, in world there are natural reservoirs are also available. Means naturally hill is only in such a shape or in such a structure that, I mean, some inlet or some water, some place, or some area is created for storage of water, which is called as a reservoir. As this area is created by itself or naturally it is done, it is called as natural reservoir. I mean, if you want water available at some heighted place, and if you are creating an artificial setup or artificial arrangement for the storage of water, then it is called as artificial storage reservoir. So water which is used is available at high altitudes like waterfalls, artificial storage reservoirs. You can store water, right? Now this water is passed through penstocks to the turbines from reservoirs, right? Now you have just stored the water at a heighted place, or you have created an artificial reservoir and you are storing water in that. Okay, that water should be passed through, and that water should come down, then only because of kinetic energy your turbines will rotate. Okay, as so that water should be passed through penstocks to the turbines from the reservoir. So that water should come down from the reservoir. I mean, water should come down means you need to pass water through some pipes. Okay, the pipes whichever you are using in hydroelectric power stations, I mean the terminology in hydroelectric power stations will name the pipes as penstocks. Okay, so penstock means it is a pipe through which water flows is called as penstock. It is passed through the penstocks to the turbines from the reservoir. This flowing water hits the blades of the turbine. Right. What happens is this water will hit the blades of the turbine, and kinetic energy is getting converted into mechanical energy. So this is happening. Right. Coming to the next slide. See, they have given reservoir at top in this in the shown diagram on the right side. They have given reservoir. Okay, from reservoir water, I mean, this is intake of water. Okay, it is taking water and it is storing in the reservoir. Reservoir will have some height and some, I mean, it will have an area for storage of water. So from reservoir, water is getting passed through the turbines, okay, by using penstock. Okay, sorry, water is passed from the reservoir to the turbine using penstock. Okay, from turbine extension is given to generator. Okay, right. At the end of penstock, you are having a turbine. Right, at the end of turbine, there is a generator, and your generator is giving, and your generator and your power lines are inside the powerhouse, and your generator is producing or is producing electrical energy, and it is giving to the power lines. Right. Next, after turbine, again the water needs to move out. Okay, I mean the water should be stored at some end. So usually it will be given to smaller rivers, or it will be flown, and that is outflow river, which is shown at the rightmost corner in the shown diagram. Right. Next is coming to the next slide. Right. Therefore, the turbine rotates whenever the water from the penstock comes and it falls on the blades of the turbine. As the blades of turbine are stationary, and a water with motion, and a water with and a moving or dynamic, a water is in dynamic motion, and that is water is moving. Okay, water is flowing. Okay, that flowing water, whenever it comes and it in and it falls on the blades of the turbine, obviously the blades of this turbine start rotating. Right. As the blades of this turbine start rotating, turbine acts as a prime mover and rotates the alternator. Right. So your blades of the turbine will rotate and they convert the kinetic energy of the water into mechanical energy. Now your turbine acts as a prime mover. Prime mover means which gives mechanical energy to the alternator. So your turbine acts as a prime mover and it rotates the alternator. Electrical energy is generated in the alternator. Now, I mean, mechanical energy is converted to electrical energy, and finally electrical energy is generated in the alternator. Means the purpose of a power plant is fulfilled. That is, electrical energy is generated as output. Right, coming to principle of hydroelectric power station, I will read the points in the slide. In the hydropower plants, the potential energy of the water at high level is converted into kinetic energy when allowed to flow down the stream. Right, as the water is allowed to flow down the stream, okay, the potential energy is getting converted into kinetic energy. Now your kinetic energy is converted into mechanical energy with turbine, which is mechanically coupled on the same shaft of the alternator. See, right, your turbine is mechanically coupled on the same shaft of the alternator. Right, I mean the shaft of the turbine and the shaft of the alternator are coupled, are mechanically coupled at same point, so that whenever this shaft of the turbine moves, then alternator shaft also will move and alternator will start generating electrical energy, okay, which converts mechanical energy into electrical energy. Right, a selection of site for hydro power station. Right, usually see, this is site for usually hydroelectric power stations are available in mountain areas or in a heighted places, like in nearer to rocky hills, like that only. You have hydroelectric power stations available. See, there are um, various dams and there are various power plants available. Lake Macintosh, Lake Roseberry, Lake Pieman. Okay, I mean nearer to lake you are having this reservoir. From that the whole arrangement is there, and down a triangular and a triangular shaped power station they are showing. So usually your hydroelectric power stations are available at a heighted places. Okay, so selection of site means while you are selecting the site for power plant, as you need to provide potential energy to the water, or water needs to have potential energy, so definitely a heighted place should be chosen. So it will be better if you choose a mountain or a hill, on the top of a hill or on the top of a mountain. If you are choosing if your if your power plant is built, then definitely it will be a good option for us. Right, and next is, this is also another another figure related to your hydroelectric power station. See, there in light blue or sky blue color, reservoir is there. Okay, how water is stored in the reservoir, and nearer to the reservoir, here at the end, at the or in the down part of the screen, you are having power company and substation. Okay, so like this your power plant, your hydroelectric power station will be constructed. Uh, this is also another, this is also, a view from far away place. Okay, how the area will be selected. Usually it will be a heighted place like hilly areas, etc. Right. Next, coming to the hydroelectric power plant, the layout which we can understand easily. Okay, each and every part are described clearly, and you can easily get to know. Right, see, on the left corner of the slide, clouds are there. Okay, from clouds you get a huge amount of rainfall. Whatever the rain which will get, how you create you build reservoirs in such a manner that whatever maximum of the, I mean on the hill or on that mountain, wherever the rain might fall, okay, this reservoir will be constructed in such a manner that all the rainwater which falls on the hill easily comes and get collects in and easily comes and gets collected into your reservoir. So your reservoir is built in such a manner that easily the rainwater which falls on the mountain or on the hill will easily comes and accumulates into your reservoir. Why? Because your reservoir needs to have more amount of water, as you are generating electricity based on the water which is getting stored in reservoir, right? Coming to the reservoir, after reservoir, at the bottom of the reservoir, some some lines, there are some black colored lines, and it is written as trash rack. Okay, trash rack is another component in I mean trash rack is also a part which is helpful. I mean, how it is helpful, I'll explain. Okay, this trash rack helps in cleaning the water in reservoir. Means, I mean, whatever as water will be flowing, okay, I mean whatever the mud or debris, whatever will form in the inside layer, or whatever will form uh, mm, on the um, will form at the bottom of the reservoir, whatever the debris or some many dust, I mean some particles of sand or whatever will get deposited at the bottom of the reservoir. Your trash racks will help in cleaning them, okay, so that water can flow easily from the reservoir, right? Next is forebay. There is a small half a semicircular structure which is where it is written as forebay. Okay, forebay helps in movement of water from reservoir to dam. Okay, usually reservoir will be at the back of the dam. Means first reservoir will be there, later only dam will come. Okay, why dam will be used is, a dam is another important part in a power plant, and construction of a dam is a huge project and it requires a lot of money. Why dams are usually constructed means, in I mean dam serves two types of purposes. The first purpose for building a dam is the, I mean as whatever the water which will come in rainy season, whatever the rivers overflow or whatever the from the rainfall, whatever the water comes, if you are able to store that water, so that remaining seasons of the year the water will be available for us. Okay, so this excess water, if you are able to store using a reservoir or using a dam, then what happens is, as dam is at a heighted place, whenever during summer season or during any other season, or if there is improper rainfall in the remaining part of the year, okay, then definitely whatever the water which is stored in the dam, it will help you, and it will help you for irrigation purpose, or for the areas which are nearby to the dam. Then definitely the water which is stored in the dam will help us, right? And next to the dam you have a surge tank. Okay, surge tank is another part which will adjust the pressure variations of water. Okay, I mean why? Because the water from the dam should be given to, or will be flown through penstocks to the turbine. Okay, the water from the dam will flow through penstocks, and it will reach the blades of the turbine. So if a penstock means, it will be a pipe. Okay, pipes means usually I mean pipe will have some, pipe will have some pressure. I mean there needs to be some water pressure for pipe. I mean, if what happens if the pressure is very low, I mean, or what happens if the pressure is very high? If the pressure is low, what happens is, even air, along with water, air also enters into your penstock. If the pressure of the water is very high, and the pipe is unable to, and the pipe is and the pipe's pressure capacity is less, then the penstock will break like a normal how we break a scale or stick. Like that, your penstock also breaks if the pressure of the water is higher than the pressure of than the penstock's pressure bearing capacity. So your surge tank is an arrangement, or your surge tank is there, it installed before a penstock, because it will adjust the pressure variations in penstock, so that stress on the penstock will reduce. Whatever may be the pressure, whatever may be the pressure of the water will be easily adjusted by the level of water in the surge tank, so that your penstock will need not face any issue, and your penstock will not break down as you are placing a surge tank in front of your penstock. Right. Next after to the next after the surge tank, it is a penstock. Okay, penstocks are the names of the in hydroelectric power stations. The technical name for the pipe is penstock. Okay, penstock is just a pipe which is connected from surge tank to the turbine. Next is your turbine. Okay, turbine, slowly they are showing like a hut. Okay, that is your turbine. As the water from the surge tank, okay, from the dam through surge tank reaches the blades of the turbine, the blades of the turbine will rotate, and and kinetic energy is converted into mechanical energy. Next to turbine, it is written as generator. As you know that generator converts mechanical energy into electrical energy. Coming to the anchor blocks, which is on the left side, bottom of the slide almost. Okay, these anchor blocks are supporting blocks. Okay, whatever the penstock which are from surge tank to turbine, through penstock, you need some support for the penstock. Okay, as you place penstock, as you need some bottom support, for that support you are using anchor blocks at the bottom of surge tank and penstock. Right, these are about the hydroelectric power station parts. Okay, I will discuss each and every power part in the next slides. Okay, let us see. This is your hydroelectric power project photos. Okay, the left one is Srisailam Dam. See, Srisailam Dam. Okay, there are 8 gates. Okay, how the water is from when you open all the gates, or spillway, you can also call gate as spillway also. What is this spillway means? Whenever the water level inside the dam reaches its maximum, what happens is if you store more amount of water than its maximum level, then there are chances that dam will not be able to bear the water above that maximum level. Then there is a chance that uh, your dam might face an issue, or your dam might collapse. So what they do is, whenever the water reaches maximum level, before reaching to maximum level only, they start, they open the gates. They open the shutters of the gates, or they open the spillways, so that the excess water, whatever is coming into the dam, will get will get discharged from the spillways. Okay, will get spill from this gates, or will get discharged from this gates. Okay, and coming to the right side of the photo, there are 26 gates. This is Nagarjun Sagar Dam. Okay, constructed on Krishna River. So here, whenever the water, whenever the inflow of the dam is high, and the storage level of the water in the dam is reached, Okay, then definitely they will open the spillways or the gates of the hydroelectric of the Nagarjuna Sagar Dam. Okay, when all the gates, when they open all the gates of the dam, then definitely it will be a very beautiful view, and it will be like a tourist spot also for the people. I mean, people from various places come and visit whenever as during the rainy season due to heavy inflow of water in the dam. All the gates, they open all the gates, and it will be like a good tourist spot also. So these are the photos about Srisailam and Nagarjuna Sagar Dam. Coming to the coming to each and every part of the hydroelectric power station. Coming to the first part, which is reservoir. The main purpose of reservoir is to store the water during the rainy season and supply the same during the summer season. I have already told that reservoir. Why a reservoir? It's just like a storage place. Okay, why? Because if you are unable to store this water, what happens is this water gets wasted. Okay, the water gets drained, or it will get absorbed by the ground. But what happens is, if we waste that water like that, I mean, if we are not constructing an artificial reservoir, the water gets wasted like that. And whenever you need, or whenever you are in need of water, like during summer season or during any other season, if suppose the rainfall is less, then what happens is, you won't be able to get water at all. Okay, you won't be able, you won't be able to get water. Then the disadvantage what happens is, I mean, whatever the crops, or I mean, for drinking purpose, the water won't be available. So that is the reason that reservoir is like a storage thing, where you try to store water during rainy season and supply the same during summer season. Right, coming to the dam. Okay, right. As the function of the dam, dam totally construction of dam. Okay, how a dam should be constructed, what are the features, and how, I mean, what are the features and where it should be located. um, there's all this, the whole thing which is related or associated with the term or the word dam will come under the civil engineering branch. And I mean, civil engineers only, they take a plan, I mean, depending on the I mean, how, I mean, what reservoir is present, or what, I mean, which river is flowing in that place. Okay, by seeing or by analyzing everything regarding inflow and outflow, how much amount of water we are able to store. Okay, I mean, how much height a dam should be constructed. Okay, I mean, again, the construction of dam also takes some, yes, takes many years. It is not a small thing or an easy thing, and again, it is associated with a huge capital. I mean, construction of hydroelectric power plant is not that easy. Even construction of thermal power plant also takes some time. But if you want to install thermal power plant, then it's not a great issue. Why? Because it is not related with storage of water. I mean, wherever the coal is available, coal will be available in coal mines, uh, or coal reserves. Wherever you have there, coal will be available. From there to your thermal power plant, you need to adjust, or you need to have transport. For water, it won't be like that. I mean, you can't get water wherever you want. So definitely everything should be designed properly. So then only, right. I have told that a dam comes under the part of civil engineering. Okay, I mean, it is associated with huge construction and huge cost. Okay, wherever you want water, there you can't take water. Okay, water wherever it is available, or a continuous like a dam will be constructed across a perennial river, like the river which flows throughout the year. Like that, rivers will be taken, and where it should be constructed nearby, what are the areas which will get affected if you construct the dam. Okay, that all the measures and everything will be observed, and civil engineers will plan it in a proper manner. Okay, it will take some years to construct and come into operation. The main purpose of the dam, I have already told that it is to store, I mean, to provide water during summer season. Okay, the second purpose of the dam is to produce electricity. Okay, right. The function of the dam is to increase the height of the water level behind it, which ultimately increases the reservoir capacity. Dam will increase the height of the water. The reservoir will just store the water, but you need to provide potential energy again. So in order to provide potential energy, you need to construct dam, and at the end of reservoir, at the reserve, then the water from the reservoir should enter the dam, and the dam should be constructed at a very heighted place. Okay, right. So behind it, which ultimately increase what is happening. What is happening means, I mean, you are constructing a dam means you are increasing the reservoir capacity. Okay, I mean, whatever the excess water of reservoir, definitely it will come into dam, or you can store a bit more amount of water in reservoir only, because whatever, I mean, however you want to adjust the water into dam, you can open the entry of the dam, and you can increase the flow of water from reservoir to the dam. Right. Next is also again a photo which is showing the spillways of a dam. So there are three spillways which are showing, which they are showing on the screen, and this is also a hydroelectric power station here. Right. Next is spillway. Spillway provides the discharge of surplus water from storage reservoir into the river downstream side of the dam. It is a safety valve for dam. Spillway. Spill means which will discharge, will throw away, spilling off. Okay, like spilling off. Right. Spillway means a spillway provides discharge of surplus water. You can we can get it out. I mean, if there is too much rainfall, or if huge floods, the city or the place has experienced huge amount of floods, then what happens? More and more amount of water gets accumulated into reservoir. What reservoir does the water? It will shift the water into dam. Okay, obviously, I mean, again, your dam, whatever the dam you have constructed, it is a huge investment, and it is a major project. Okay, it takes some years to construct, and it is associated with a lot of cost. Suppose unknowingly, if the water that is to be stored in the dam, I mean, water that is to be stored in the dam, it has crossed its maximum level. Then what happens is, there is a chance that because of over storage or because of the pressure of the water, there is a chance that, I mean, as the ages pass for the dam, I mean, due to aging also, I mean, there is a chance that your dam might collapse. Okay, but this should not happen. Why? Because it is associated with a huge investment, and it is associated with a huge manual, this huge effort also. So what they does is, they decide a maximum level for storage of water. Whenever the water in the dam reaches that maximum level, this spillways will come into picture, and they will play a major role, and they will open and the spillways, or the gates of the dam. So they construct gates for the dam, so that if the water in the dam reaches the maximum level, then they can open that spillways, or they can open that gates, or they can open the shutters of the gates, and they can disperse the excess flow of water in the dam. Okay, this is one of the reason, and this is the reason why spillways are there in a dam. It is a safety valve for a dam. Safety valve means, safety valve means it protects the dam from any damaging, or from any collapsing. Right. The next is coming to the next part. This is also a photo of regarding spillways or gates of the dam, where the water is coming out. And right, in the last time, at downside there will be a stream. See here, at the bottom there is a stream, or there is a river where the water where the discharge water comes and makes up it. Some people call it as a tail pond also, or they construct a tail pond nearby the dam, so that the water which is getting discharged from the spillways or the gates of the hydroelectric power station dam, okay, from the gates of the dam, that will come and gets stored in your tail pond, right? Coming to what is forebay. Okay, the forebay serves as a regulating reservoir, okay, temporarily storing water when the load on the plant is reduced, and provides water for peak load hours, right? Forebay means, I have showed in this diagram that forebay is a point, is in between reservoir and dam. Directly water can be given from reservoir to dam. Why a forebay is there in between means, it regulates the water. Suppose that if suddenly if suddenly the demand, suppose it is a peak load hour, okay, peak load hour like evening 6 to 8 p.m. Okay, suppose it is a peak load hour and the demand for electricity is more. If the demand for electricity is more, what happens? Definitely more amount of water you require in the dam. Okay, immediately then what should happen? Dam should, water should come out from the from the reservoir, and it should enter into the dam. Okay, during peak load hour, or if suppose during midnight, like that, you don't require any electricity from, there is no requirement of electricity, then what should happen? Then what should happen? Then the level of the dam, I mean, then the water level in the dam should be reduced. Okay, so from reservoir to dam, or from dam to reservoir, immediate intake of water into dam, outtake of water from dam is not that easy. Okay, I mean, for us, as we are seeing in picture, both are side by side. We feel that, I think it might be easy for flow of water from reservoir to dam, or dam to reservoir, but it is practically, it is not that easy. So they are providing a forebay in between reservoir and dam. What this forebay serves is, if suppose forebay also stores some amount of water in it, if suppose during peak load hours suddenly the water is required, so immediately from forebay the water enters into the dam. So there won't be any much won't be any much consumption of time, and operation will be done easily, and during peak load hours the demand also will be satisfied, the demand also will be fulfilled, right? That only they have explained here. I'll repeat it once again. The forebay serves as a regulating reservoir. It is also like a reservoir, but it regulates water in that. Okay, temporarily store it, I mean, it stores some amount of water only, temporarily storing water only, and it is, and I mean, there is no condition that forebay will permanently store that water only. Okay, and temporarily stores that water when the load on the plant is reduced, and provides water for peak load hours. If suppose suddenly they have reduced, if suddenly they have reduced the load, I mean suddenly the demand is reduced, so what they do, from dam again the water doesn't need to go back to the reservoir. From the dam the water will come and it will get stored in forebay. I mean, it will be like it will be like an emergency need. I mean, whenever more amount of water you require, from forebay some water will be sent to the dam. Whenever the requirement of load is less, or whenever the demand is less, then immediately the water from the dam comes to the forebay. I mean, it reduces the stress of water moving from dam to reservoir and reservoir to dam all the time. Okay, it will serve as a regulating reservoir. This is about your forebay. Right, coming to the trash rack. Okay, these trash racks are of different size. I mean, some will be of sheets or plates. Okay, the water intake from the dam is provided with trash rack to prevent the entry of debris which might damage the turbine runner of the impulse turbine. Right, the water intake from the dam. Right, whatever the water which is being sent to the dam, the water intake from the dam is provided with trash rack. Okay, before the dam only this trash rack is provided. Why? Because I mean, this is water. I mean, we are getting water collected into the reservoir. I mean, during rainy season or whatever. I mean, from mountains or from hills, wherever the river is flowing, from there we are getting water into reservoir, or it may be a rainwater also. Whatever may be the water. As they are, as it is falling from many. As it is not directly coming into the reservoir, as it is coming from mountains or hills, or even if rainwater also, it is not compulsory that all the rainwater will directly come into the reservoir. It will fall on the rainwater will fall on that mountain, and slowly it will get accumulated into the reservoir. While getting accumulated, or while the while coming from different mountains or hills, some grass, sand particles, stones, even debris, everything will come along with the water also. Okay, if suppose if we are not checking that, or if suppose we are allowing that water only to flow through the tank, through the penstocks, and if that water is reaching the turbine, there is a chance that your turbine might damage, or there is a chance that this debris or this stones or whatever the waste particles are there along with your water, there is a chance that they might get accumulated in penstock also, or they might also obstruct the flow of water in the penstock. So what it does is, before the water from reservoir, sorry, the water before entering into the dam from reservoir, they provide this trash rack arrangement, so that this debris or this mud particles, sand particles, or small sized stones, whatever are there, they will get stocked or blocked there itself, so that the water which enters into the dam will be free of all these risks. Okay, and from there, water from the dam will enter the penstock, and easily the water will touch the blades of the turbine, and the turbine will rotate. Okay, and the turbine will give mechanical energy as output. So by this trash rack arrangement, what happens is, what happens is, okay entry of debris, and the stone particles or whatever mud particles, grass, whatever is there, that all will be stopped, and water will not get blocked even in your penstocks, and water will be allowed easily to pass. Okay, so this is the importance, or this is a necessity why trash racks are needed in your hydroelectric power plant. Just I will show you the diagram. I will show you the name where trash rack is used in our power plant. Whatever the diagram you see, trash rack is before at the end of reservoir only. At the end of reservoir only, before entering into the dam only, you are having trash rack placed. Okay, all right. Right. In today's class, I have discussed about various parts of hydroelectric power station, and I have spoken about Nagarjuna Sagar and Srisailam dams also. Okay, there are much more interesting parts which are left over regarding hydroelectric power station, which I will cover in next classes. Okay, for today I will stop here with introduction of few parts about hydroelectric power station. Thank you so much. Okay, right.